Imagine we have some very massive body out in space, like a star or a large planet, and there's some small object with much smaller mass that's moving around in the gravitational field of the large massive object. What shape would its orbit trace out? Well, you probably have heard, or you may know that according to one of Kepler's laws, the orbit traced out by this object orbiting the very massive central object makes an ellipse with the large object at one focus of the ellipse. But in fact, it's more general than that. You only get an ellipse if the object is moving so slowly that it actually can't escape the gravity of the massive central object. But if you had some object out in space here that was moving very, very rapidly, it could escape the gravity of this large central object. So what would its orbit look like then? It couldn't be an ellipse because we already said it was going to escape the gravity of this central object. Well, gravity would pull on this for a while to curve its orbit, but the object is going so fast that eventually it's just going to sort of go off far away from the large central object. And, if you trace the orbit backwards, it would look something like this. And that looks kind of familiar. That looks like a hyperbola. And indeed, it is a hyperbola. It turns out that if you have a large central body and you want to know the orbit of any object moving under the influence of the gravity of the large central body, the orbit always traces out a conic section. So if the orbit closes up, as this is called a closed orbit, you always get an ellipse. If the object is moving too rapidly to be captured by the gravity of the central object, then you get a hyperbola. And if the object is moving only barely rapidly enough to escape the gravity of the object, then it turns out that you get a parabola. So it turns out that parabolic orbits sort of sit in between elliptical orbits and hyperbolic orbits. And that's probably no surprise because the eccentricity of parabolas, which is 1, sit exactly between the eccentricity of ellipses, which is less than 1, and the eccentricity of hyperbolas, which is greater than 1.